So you've probably seen that little padlock icon in your browser's address bar, right? Maybe you've even noticed how some websites show HTTPS instead of just HTTP. But have you ever wondered what's actually happening behind the scenes to keep your data secure? That's what we're breaking down today. The SSL/TLS handshake, which is basically the secret conversation your browser has with websites before sending any of your information. And trust me, this stuff matters more than you think. Every password you type, every credit card number you enter, every embarrassing search query you make, all of that is getting protected by this process. So let's figure out how it actually works. What even are SSL and TLS? First things first, we need to clear something up. SSL stands for Secure Sockets Layer, and it's basically a protocol that was designed to encrypt data as it travels between your computer and a server. TLS, which stands for Transport Layer Security, is essentially the upgraded version of SSL. Better security, fewer vulnerabilities, all that good stuff. Here's the thing though, SSL technically doesn't exist anymore. The original SSL protocol was created back in 1995, and it was deprecated years ago because of security flaws. But the name SSL just stuck around because it's catchy and everyone knows what you're talking about. So when people say SSL today, they're almost always actually referring to TLS. It's kind of like how people still say rewind, even though we're not using VHS tapes anymore. For the rest of this video, when I say SSL, just know I'm really talking about TLS or whatever modern security protocol is being used. The concepts are the same. Why do we even need this? Okay, so why does any of this matter? Well, here's something that might freak you out a bit. The internet is basically just a bunch of cables connecting your computer to other people's computers. There's no magical cloud in the sky. Cloud storage is literally just someone else's computer sitting in a warehouse somewhere. When you connect to the internet, your data is traveling through cables, through routers, through servers, through all kinds of infrastructure that you don't control. That's incredibly convenient, but it's also a massive security risk. Think about it. When you buy something online, you're sending your credit card number, your address, maybe your date of birth through dozens of different computers and network devices before it reaches the store's server. Without encryption, all of that information is just sitting there in plain text. Anyone with the ability to intercept your connection could read everything you're sending. Your passwords, your messages, your banking information, all of it completely exposed. That's where SSL/TLS comes in. It encrypts your data so that even if someone does intercept it, all they'll see is scrambled nonsense. How to spot a secure connection. You can tell pretty quickly if a website is using SSL/TLS just by looking at the URL. If it starts with HTTP, that's unsecure. Your data is being sent in plain text. But if it starts with HTTPS, that S stands for secure, then the site is using some form of encryption to protect your information. Most modern browsers will also show you a padlock icon next to the URL when you're on a secure site. Some browsers even go out of their way to warn you when you're about to visit an unsecure site, especially if you're about to enter passwords or payment information. The handshake process. All right, so how does this whole SSL/TLS handshake thing actually work? When you visit a website that uses SSL/TLS, your browser and the website server need to establish a secure connection before they start exchanging any real data. They do this through what's called a handshake, kind of like how you might establish trust with someone before sharing personal information with them. The exact details of this handshake can vary depending on what version of TLS is being used and what kind of encryption methods your browser and the server support. But the basic flow is pretty consistent. Step 1, the client hello. Everything starts when your browser sends a message to the server saying, "Hey, I want to connect securely." This is called the client hello message. In this message, your browser is basically introducing itself and saying what it's capable of. Specifically, it tells the server what version of TLS it supports. Maybe TLS 1.2, TLS 1.3, whatever. It also tells the server what cipher suites it can work with. A cipher suite is basically a set of encryption algorithms that can be used to scramble the data. Different cipher suites offer different levels of security and performance. Your browser also includes some random data in this message that'll be used later in the process. Step 2, the server hello. Once the server receives your browser's hello message, it looks at all the options and picks the best combination of TLS version and cipher suite that both the server and your browser can support. Usually, it'll pick the strongest encryption that both sides can handle. This is why using an outdated browser is a bad idea. If your browser only supports old, weak encryption methods, that's the best you're going to get even if the server can do better. The server sends back its own hello message with its choices, and then it also sends something really important, its SSL certificate. The SSL certificate. The SSL certificate is like the server's ID card. It includes a bunch of information about the website, but the key things are the domain name, information about who issued the certificate, and most importantly, the server's public key. Your browser takes this certificate and checks it to make sure it's legit. It verifies that the certificate was issued by a trusted certificate authority, basically an organization that vouches for the identity of websites. If the certificate is expired, or if it was issued for a different domain, or if it comes from an untrusted authority, your browser will throw up a big warning screen. Quick side note for anyone running a website. You need an SSL certificate and you need to keep it up to date. These certificates expire usually every 90 days, specifically so that if a certificate gets compromised, it won't be valid forever. Modern browsers will actively stop users from visiting sites with the expired certificates. So if you're managing a website, make sure you're monitoring your certificate and renewing it before it expires. Step 3. The key exchange. Alright, so now your browser has verified that the server is who it says it is. The next step is to agree on a key that both sides will use to actually encrypt the data they're sending back and forth. This is where things get interesting. The server sent its public key in the certificate, and public keys are used in something called asymmetric encryption. With asymmetric encryption, anything encrypted with the public key can only be decrypted with the matching private key, which only the server has. Your browser generates a random session key. This is the key that'll actually be used to encrypt all the data for this session. But to send this key safely to the server, your browser encrypts it using the server's public key from the certificate. The encrypted session key gets sent over the internet, and even if someone intercepts it, they can't decrypt it without the server's private key.